Alright, here we are on the homework day 4. Okay, we should have domain out, range out, y, x, max, min, increasing, decreasing, rate of change. So all we have left is positive, negative, and end behavior. Okay, so positive and negative are the intervals. So we'll do those ones first. Positive is whenever it's above the x-axis. Okay, so check your x-intercepts. That's going to key you into where it changes. Okay, so as we can see, positive is green, so from negative 4 to positive 3, it's a positive, it's above the x-axis. Once it hits 3, it goes down negative until we get to 5. Alright, so let's take a look at the next one. Okay, we should have already done question 3 and 4. If you haven't, do it now. Okay, so positive. We start up positive until we hit negative 5. So negative 6 to negative 5. Then at 1, we're going to jump up positive again. But first, we go down negative. Right? So from negative 6 to negative 5, we have our first interval of positive. Then from negative 6 till we get to positive 1, we have our negative interval. Then from 1 back up to here, which is the x value of 6. So jump, and then from 1 to 6, we get another positive. And there's our 2 intervals of positive, 1 interval of negative. Gives us our whole information. Okay? Alright, now if we look at number 5, we start out negative at negative 0.5 till we hit, I believe we called that negative 0.35. So at that's positive, not negative. Move this down a bit. So at negative 0.5 to about negative 0.35, it's negative. Then it switches to positive, goes up positive till we get to 0.5. So negative 0.35 till we get to positive 0.5. Then it's going to jump. Negative back again, so it jumps again. And we called that 1.35. So it goes from 0.5 to 1.35. Then it jumps back positive. And positive from 1.35 to 1.5. Okay? So, once again, our intervals, the x values, here to here for negative, then here to here for positive, back to negative, and finally back to positive. Alright? Okay, now number 6, it's all positive, isn't it? It's all above the x-axis, so from 0 until we get to 13. So 0 to 13. Now negative, it's never negative, or you could write that empty set. Just blank parentheses. Never thought that just something blank would be an answer. But it is, sometimes. Alright, now for tables, even easier, right? So from negative 2 to negative 1, it's negative. So negative 2 to negative 1. Then from negative 1 down to 4, stays above the x-axis. So negative 1 to 4 stays positive. Tables are pretty easy, right? Because they're staring you right in the face. And this one, all positive again. So from our lowest, negative 6, or most left number, to our most right number, positive 6, is positive. So negative becomes never, or that empty set. Okay, number 10, we have already done that one. If you haven't, make sure you get that one done. Alright, now we look at this one. Once again, all positive, from negative 3 down to 6. So negative 3 to 6. And negative, empty set, or never. Okay, we don't have to do 13, so number 12 again. Okay, all positive. So 0 to 6. And negative is never, or the empty set. So that one turned out to be pretty easy, didn't it? That positive or negative. Okay, so now let's go back and do the end behavior. Now with end behavior, if I were to graph this one, it would actually be an exponential if I connected the dots. Okay, so it wouldn't get below a certain asymptote, but we don't know that. So I just go as it goes left, so the leftmost point is going to 0. And as it goes right, the rightmost point is going to 729. Because I didn't know if it was going to be an exponential and continuous. So I have to assume it's discrete, because that's all I can say about it. Alright, so end behavior here. Our leftmost point, so left goes to where? It's going to 100. And our rightmost point, when we go to the right, where's our graph going? Where's our table going? Going to 50. And that's all there is to end behavior. Okay, so we've got left, where's it going? And right, where is it going? So left would be -6, going to 20. Right would be +6, going to 4. I mean, it does hit 4, but because these are finite, they're discrete, they stop. That's all we're kind of left with. Alright, number 7, as it goes left, and as it goes right. So -2 goes to -5, +4, the rightmost point, goes to 2. In our graphs, same idea. As it goes to the right, we hit this point, which is 6. So right goes to 6. As we go to the left, we're hitting that point, which is 10. Same with this one, as we go right and as we go left. Well, as we go left, it's going down to -2. And as we go right, it's going up to +2. Simple enough. So we're almost done with this whole worksheet. It's been quite some time. Maybe not a ton of time altogether, but we've really dragged this out, haven't we? So as we go to the right, it's going here to 5. And as it's going left, here at 1. That's all there is for us to end behavior. As it goes right, it's going down to -5. And it goes left, it's going to 3. Now remember, if I had arrows here, that would change the whole thing, wouldn't it? Okay. If this graph went up like this, and if this one kept going down, then as we went right, we'd be going to -infinity, and as we went left, we'd be going to +infinity. But that's only in those cases where we have functions that are continuous and they keep going. So, alright, this one should be done. Make sure you've got it all finished. Every answer done. We've had plenty of time to work on it with no extra homework. So make sure you get that handed in.